Use induction to prove that for all n natural number n greater than 0, 1 cube plus 2 cube plus n cube equal to 1 over 2n times n plus 1 all square. Okay, so we need to prove it for n greater than 0. So n greater than or equal to 1. Base case is the smallest n, so n equal to 1. So this is our p of n, right? We need to prove that p of 1 is true. So we need to show that p of 1 is true. So what does that mean? What is p of 1? P of 1 is you go n until you reach 1. So n equal to 1. So we stop right here. Nothing, we don't have this. So n equal to 1. We have left hand side is 1 cube. 1 over 2 times 1 plus 1 all square. And this means that 1 equal to 1. So this is true. And this is in fact p of 1 right here. So base case n equal to 1, p of 1 is true. Now we do the inductive step. So inductive step, what do we need to do? We let n be a fixed natural number. N greater than or equal to 1, right? Greater than or equal to base case. Suppose as p of n is true. This means that this is true. P of n is true. And we need to show p of n plus 1 is true. P of n plus 1 is true. This means p of n plus 1 means that p of n plus 1, so we go until n plus 1. So this is p of n. And p of n plus 1 is this statement. We go until n plus 1. So 1, 2, 3, n plus 1. Okay. The right hand side, every time you see n, we replace it by n plus 1. So 1 over 2. The first one is n, so we have n plus 1. Second one is n plus 2. Square. The left hand side p of n plus 1 is this. Left hand side equal to this. This equal to, we know the values of the sum of the first n terms, right, by inductive hypothesis. So here we call it the inductive hypothesis. Okay, so using the inductive hypothesis, we know that the sum of the first n term is this value. And plot the last one. And this is true because of inductive hypothesis. So this equal, now we do the computation. So this equal to 1 over 2 square, right? So 1 over 2, just put it right here, times n square, n plus 1 square, plus 2 square over 2 square times n plus 1 to the 3, right? So then we can put 1 over 2 out there. Inside we have n squared, n plus 1 squared. We have 2 squared, so 4 n plus 1 cubed. So what is this? This gives us, so there are two ways. So first one, we just compute it, and we compute the right hand side, and we check that they are the same. So that's the easiest way. So other way you can do it like this: 1 over 2 squared. So n plus 1 squared. We'll put it out. N plus 1 squared. Inside we have n squared plus 4 n plus 1. Yeah. So what does that mean? 1 over 2 squared, n plus 1 squared, n plus 2 squared. Right. So this is n squared 4n plus 4. So n plus 2 squared. This done. So this means that this is 1 over 2 n plus 1 n plus 2 all squared. So this is exactly the same as the right hand side. Right hand side of p of n plus 1, and therefore p of n plus 1 is true. And by induction, by principle of mathematical induction, p of n is true for all n, right? By principle of mathematical induction, for all n in n greater than 0, p of n is true. And we are done.